Hello and welcome back to our audit kickoff streams. My name is Jess and today we have another exciting project for you to dive into. Today we have the Curve contest going live on the CodeHawks platform, and in this stream we're going to have the developers go through the code base and give you a technical overview so you know what to expect when you head into this contest. Now before we invite them to the stage, I just want to quickly walk you through how you can reach this contest on the CodeHawks platform. So if you go to codehawks.cyfrin.io and you go to competitive audits, this contest has literally just launched this second and it's live for 1 week. We have a prize pool of 14,723 OP and we have an end slot of 394. So if you are looking for a reasonably small code base, then this is a contest that is for you. But before we get into the information, I think we should bring the developers on to the stage. So please welcome Alberto and Roman. They are the developers of this code base and they are going to be sharing their screens and talking us through the code base. So if you two could please quickly introduce yourselves and tell us about what you're doing at Curve.
Yes, hello, I'm Roman. I'm the guy who made this solution and implemented it. And I'm smart contracts developer at Curve.
Hi everyone, Alberto, smart contract dev at Curve. I've been kind of mostly reviewing what Roman has been doing, and I guess I work mainly on the AMM. So if you have any questions related to that side of things, I can help you out.
Amazing. Thank you both very much. Before we do get started, if you do have any questions during this stream, then please put them in the live chat and we will have them answered at the end. And if not, head over to our Discord where we've got a channel open specifically for this contest where you can ask Roman and Alberto questions about this repo and get them answered. Now, time to get started. Roman, are you able to share your screen and give us a technical overview of these contracts?
Yes, 1 moment.
Thank you.
You see it, right?
Yeah, there we go.
So first, to cover the context about what the project is about, I would say about savings vault for scrvUSD. It's also called savings scrvUSD, which is a risk-free interest rate stablecoin. It continuously accrues some scrvUSD from mint markets to solve some supply and demand ratio problems that we had. So the main thing to take in mind that it's always accruing some scrvUSD. You can see the contract here. Also, it's implemented as a YEarn Vault version 3. It is audited by Chain Security. You can see the report here. And the main function would be process report. Like this is the main contract that you would look to because it is working, because our contracts in the scope are working against this vault exactly. So, and Alberto is the guy who made it working. So
yeah, so if you have any questions about scrvUSD, I worked on that. So feel free to ping me on Discord.
Cool. So what's the issue we have with the scrvUSD? It lives on Ethereum mainnet, and we need it on other networks. And if we bridge it from Ethereum to, say, Optimism, we have a basic ERC20 contract that lacks the price per share function, which tells the price of the this one, and some others, but like mainly we need this one to use it in our protocol. For example, stable swap pool. What is a stable swap pool? It is an AMM, like Uniswap version 2, but it is concentrated around some Oracle price. So if this Oracle price far from the actual value, the liquidity will go beyond it, and the pool will go under the water. So we need this price up to date and constantly updating. Optimism has a great block cache Oracle, which works, which is natively integrated. So even if there is some Ethereum block reorg, it recalculates all the blocks on Optimism and updates this block hash. So it's always it always has a true value. So we have zero trust assumptions when we use this block hash oracle. Also, since we will reuse this code, we will use some networks don't have this block hash oracle, so we have to get some assumptions, and I wrote them here because we will use some trustworthy, less trustworthy oracles. So how do we take the price? Since we have block hash oracle, what is block hash? It's a hash of this block header with many fields, but mainly we need state root, timestamp, and a number. So state root is some hash of the tree of different account states. By account, I mean both at the contracts and externally owned accounts. And when it's a contract, because in our case it's a contract, it has also a state root, storage root, that is a tree of all the storage variables, all the storage slots. So by providing the block header, we can verify that the state root, number, and timestamp are correct, and then we provide the proof for account stage storage root, and verifying it against this state root, and then we provide the proof for all the storage variables, all the storage slots, and then we can replicate the I'll show here in the contract. Here is in the scope. So version 1 and version 2. Here we have all these parameters needed for the price calculation. We just store which storage is being used, and here we verify the block header, check the block hash, then extract the parameters, taking it from the proof, and forwarding it to our oracle that handles it later. So it also uses some libraries from XDAO. They are also audited by chain security, so no need to audit them. And also there is another version with state root to use it on other networks. So it just skips the block header part. And second version is used because of the another price function. It also needs to store another parameter which is called profit max unlock time. So it's inherited from the version 1, and then same thing with this parameter. So next, what do we do with these parameters? We can go to the contract. Basically, we replicate the logic from this Vault v3 contract, but minimizing it to just a few calculations because we don't need to store everything. There are basically 3 functions. First one is very easy. It means like read from Ethereum at this point. So it just stores the one value of the price. You can see like here are the methods. They are called just the same as in the vault, so you can follow them directly. And it calculates at some timestamp where the block was given. Then another one more interesting is price version 1. It assumes that no one interacted with the contract with the scrvUSD on the mainnet anymore after the proof was provided. So here our timestamp will go further, and this function will actually work because in the V0 it's just same timestamp, so same value here, same value here returned. So now it's acquiring some more scrvUSD and follows the price. So it's not the 100% accurate. We can allow for a small error to be. This works. And actually, even version 1 is already working good. It needs only a couple of updates per week. And we have this period where we distribute the rewards is equal to 1 week. So 1.5 period. And the most interesting one is the version 2. So it assumes that we have the constant reward coming to the scrvUSD, denominated to the savings vault, denominated in scrvUSD. I mean, like every week we distribute, say, 1,000 scrvUSD. So in this scenario, since the function works only for 1 period, we need to obtain new parameters that were verified before. And here comes another function. This is needed only for the version 2. And I go in some details here. Like you can see in process report, you can see some variables like gain. So this one is this function is made was reduced from the calculations here with this assumption that gain is constant, and also no one is putting in money or withdrawing. We can assume this because rate is more or less stable or just fluctuates a bit, so the error from it is not huge. Here we get the gain, then we add for the number of periods that went through for the time. And then this is like magic formulas that I couldn't like write how did I get them, because it is actually reducing from this function process report, just following every step like with these assumptions. Yes, and then updating, like this is the copy paste from like here, right? Copy from process report, just 1-to-1. And another thing that we have for the prices is smoothing. For example, imagine if the keeper bot that verifies these parameters goes off for a long time, then the price changed a lot. And if we verify, there will be a price jump, which can lead to sandwiches or other math EV opportunities. So in this oracle, we have the smoothing, let me find it, to smooth price, which has some maximum price increment, the safe value in which price can jump, so there are no opportunities to arbitrage it, or actually arbitrage it while incrementing the actual price. So this one is put over all the functions. You can see the here it's used everywhere, and the value is made so it is some trade-off between the highest possible APR and it's I mean it's big enough so it can actually keep up with the price. And also there are docs with the whole picture where there is a prover. It's a keeper bot that we run on our side, or anyone can run it. It takes the state proof. It checks that if the price is too far from the one we need. It provides the block header, the proofs of every storage variable. Put in the verifier contract. The block hash is verified against this recompile on Optimism, or this can be changed to any other. And then pushes the price to the price Oracle contract. And then it can be used anywhere, in stable swap pools or lending markets or anything. Maybe that's it. Alberto, do you have something to add?
You're on mute. Hold on. There you go. Did that work?
No, you should hear me. Yeah, so all good on my side. I think maybe I can just do a quick recap just to wrap up and give some like the big picture of this thing. So basically the idea is simple. We have a scrvUSD vault, which is a Yarn v3 vault. It's kind of the same idea as SDAI. The idea is on mainnet, it just works well. It's an ERC4626. So we just can obtain the rate to concentrate liquidity correctly using the native view function in the Yarn vault. Thing is, when you bridge this to when the token gets bridged, it gets converted to a normal ERC20, so we lose the capacity to obtain this rate. And the way we get it back is through storage proofs. So basically, what we do is we look at the state on mainnet. We can create a proof that of that state, and we can bridge the state with some keeper to all the other chains where we need to have a precise oracle of the rate. We have 3 different versions of the rate, V0, V1, and V2. Each one is a step more sophisticated. We have multiple versions because some of them are already in production, and even though they're not super precise, they work reasonably well. And then we're trying to get to a point where we have something that approximates in an almost very precise way. The way in V2, we have approximated this, in the price V2, we have approximated the rate so precisely because we have reduced we have simplified the process report function from the Yarn v3 vault, which is responsible for the price increase, in a way where hopefully it tracks the price quite correctly. So there is technically no trust assumption on the safety of the proof because you cannot really forge a proof. But there is some trust assumption on liveness that because the keeper has to stay live, and this is something we try to mitigate in the smart contract side, as Roman described. Hope this is clear. If there's any questions, I'm happy to answer them.
Amazing. Thank you very much, both of you, for that deep dive and that walkthrough there. As we have said, if you do have any questions about the contracts, then head over to our Discord, and both Alberto and Roman will be in there to answer your questions throughout the next week. This contest will be live for exactly 1 week, and it did start at the same minute that we started this live stream. So you've got 1 week to get involved. Maybe watch this live stream over a couple of times because there's a lot of information in there, and that should give you a head start into this contest. Any closing thoughts, Alberto, Roman, before we close this off?
All good on my side. Thank you, Jess.
All good.
Amazing. Well, good luck to you all who are entering. Thank you very much for joining us, and we will see you all soon. Goodbye.
Bye-bye.